Thank you. Thank you, everyone. Great to be here and to chat about synthetic data applications in MMMs. Um, I'll take the first stab at the presentation. I'll walk everybody through sort of what synthetic data is, how is that being applied to MMMs, why do we need synthetic data, why do we need to bring synthetic data into MMMs, and then I'll pass it over to Robin, who will be talking about her experience with working with MMMs and more from a practitioner standpoint of why we should leverage such technology. MMM should not be very new to this group, but synthetic data might be. So I thought it'd be better to start off giving an introduction of what synthetic data is and certainly why people use synthetic data. In short, synthetic data is simply data sets that are generated by an algorithm. So they're not collected. There's no survey. There's no tracking. There's no nothing. It's simply writing a computer program to generate data. That said, we're not simply just making stuff up. Synthetic data is not random data. Synthetic data is generated in such a way where key characteristics of the original source is being preserved. So usually that could mean things like statistical properties, like the mean, the variance, the correlations, and so on. In other words, we want to generate data sets that look like the original, even though they are not the original. Synthetic data is all around us, even though people don't necessarily use the term synthetic data. If you imagine ChatGPT, that is in some ways a form of synthetic data. You take some text, you train a model with the given text, and you use the text to generate more text, so to say. So anything that ChatGPT is giving you is not authored by any real person. It's not really real data. That said, it looks just like someone has written the text, and it carries useful information. And that's the whole point of synthetic data. Same thing. If you take pictures, if you take lots of images, you put it through Midjourney, and you ask the computer to generate more images. Well, that's also a form of synthetic data. Again, not many people, a few people recognize sort of text and images as data sets, but they are actually really data sets. And of course, what we do at Arima as well, we take tabular data, in particular, tabular data in the form of consumer intelligence, consumer behavior, and we use that to generate more consumer data. All same kind of an idea. So what's the motivation behind creating synthetic data? Well, for marketers in particular, there are two things you're looking for. You're looking for privacy compliance. So you want to make sure that the data sets you're using are privacy compliant. There's no re-identification risks. There's no use of personally identifiable information. There's no you're you know you're making sure people are giving you consent when you use this data set. So that's one thing you want to make sure. And then the other thing you want to make sure you want is to have unified profiles. In other words, across all of the platforms that you have, you want there to be a way to be able to connect all of the different data sets. So whether that be your CRM data or your, Google Analytics, Facebook profiles, credit card data you're buying, mobility data you're licensing, all of these information you have access to, you want them to be able to somehow connect so you get the 360 degrees view of your customers. Now, one thing you'll very quickly realize is 1 and 2 are contradictory. If you have more compliance, that means it's harder for you to track. That means it's harder for you to build better profiles, unified profiles, and your data is going to stay more fragmented. And if you want more better ways of connecting your profiles, you need to be able to track people better. You need to have better identities, and therefore you are going to violate number 1. So you can't get both, even though that's what you want. Synthetic data is a good way to address both problems because synthetic data sets, as we talked about before, are generated by a model as opposed to collected based on real people. So the advantage of generating data sets is that 1, your synthetic data is not expected to be exactly the same as your original. In other words, here I have an example. Um, People typically call this differentially private, where you have your original data set. You develop a model and you use the model to learn key characteristics from this data set, and you use that model to generate another copy of that data set. If you do a row by row comparison, none of the cells will look exactly the same. They'll all have different values. That said, if you calculate your statistical metrics like your means, your variance, your correlations, or if you were to train a model on one data set and use it to predict the other data set, um, you'd expect your analysis to be statistically equivalent when performed on both data sets. Um, there are, of course, lots of technologies over the years that people developed on how one could generate synthetic data sets like this. The other thing that synthetic data sets can do um, is to help you join data sets by sort of creating something out of nothing, if you will. It may not be as easy to visualize tabular data, but I have a picture here of images, and I think when you look at that, it'll make a lot of sense. You have one data source where you have the person, and then you have another data source where you have the clothes. You don't have a data set with the two joined together, but that's okay. You can develop a model, and you ask the model to learn key characteristics of what this person looks like and what the shirt looks like. And now you ask the model to generate a picture with the person wearing that shirt. So what's in this image never existed in real life. However, it's built based on two real sources, and it gives you very useful information about what would happen if you have that one person wearing that clothes. So synthetic data generation, same kind of thing. We train models on multiple data sources. They're not necessarily connected. They're just distinct, separate objects. But now, once the model learns key characteristics from both data sets, it can then help you fuse the two together, create a data fusion based on two distinct things, like we see here in the image. So now that I've talked a little bit about what synthetic data is, I want to sort of introduce to everyone what we do at Arima, what is specific to synthetic data, and how we apply that to MMMs. So with Arima, we've created a data product called the Synthetic Society. As the name suggests, synthetic because it's synthetic data. It leverages the same kind of synthetic data generation algorithms as we've talked about up to this point, and society because it's built to mimic the real society. So, think of it like a digital twin of the world population, or a virtual ID model, a parallel universe, however you like to call it. But it's essentially a data set, a large data set that contains the exact number of people as how many ever real people live in a particular part of geography. So it's a modeled version of the real society. It's granular. We have just as many individuals as how many ever individuals there should be in a particular area. It's localized and indexed by geography. This is really important because synthetic society has no identity. Synthetic data has no identity in general. Indexing people by geography is probably the best thing you can do. And certainly when you generate synthetic individuals, there's no privacy concerns because we're not actually tracking anyone. We're simply creating creating a lookalike based on all the information we have from available sources. The way I think of synthetic society is it's kind of like an LLM with people as tokens. As I'm sure most of you know, for large language models, you use words as tokens. You have a sentence, you have some missing words, you put it into the LLM, and the LLM spits out missing words and helps you complete that missing sentence. For us, the synthetic society, we use people as tokens. You take a person, you know something about that person. Maybe they're your customer, maybe you're your prospect. You know some things about that person. You want the synthetic society to help you complete the missing attributes for that person. And that's essentially what it does. It's technology that we've published over the years, and here are some links to papers that I've written. And here's the final link to MMMs. Here at Arima, we build both the synthetic society and also a number of applications on top of the synthetic society. So think of the synthetic society as foundational layer where lots of different data sources are coming in and models are trained on the input data source to then generate a mimic version of the real society. And based on the synthetic society, we then develop many more applications that serve various applications, various use cases of how um, uh, helping people leverage the insights within synthetic society. So marketing mix modeling is certainly one of them. There are a couple of others we have that it's quite obvious the names should be pretty self-explanatory, but we won't go into that in detail. MMMs should be fairly familiar with this group. Of course, MMMs are quite a standard choice now for companies that are looking at measuring media efficacy, measuring the media performance. Here I have a slide on the different MMM options out there. MMM is going through rapid changes now from the traditional MMMs where it's more ad hoc, it's full service, to open source frameworks like Robin or Meridian, to enterprise solutions, and also to a sort of SaaS-based, platform-based MMM solutions. So it's a quick summary of what's out there in the market. And here I'm trying to say this, that a lot of people are looking at MMMs and a lot of people are spending time making MMMs better in every imaginable way. Before I wrap up and pass it over to my colleague Robin, I want to just quickly discuss why we bring the synthetic society to and integrate that with the MMMs. Synthetic society could be its own thing. It provides insights, it provides information about people. And then MMM is this other thing out here. It takes the client's first party data. You feed into your MMMs your historical media spend, your historical sales data, and you ask the MMM to help you make forecasts or to measure which channel gives you the best ROI. So how does these two things come together? What's the advantage of adding the synthetic society into an MMM? There are four reasons why people should look at combining the two together. And these are also what we tell our clients why you should consider not just leveraging an MMM, but enrich it with as much information as you can. So reason number one, better forecast with first party and third party data. As I'm sure you know, MMMs have the ability to make forecasts. And typically the way people done it today is they use historical sales, some form of time series analysis or some form of forecasting based on a future media plan. So they might say next year, if I plan to do this, if I plan to spend this much money, this is how I'm getting, this is the type of sales I could get. There's nothing wrong with that. This is perfect. And even in our MMMs with synthetic society enabled, first party data is still the primary driver behind making forecasts. That said, adding synthetic data, such as adding population data into the MMMs, such as understanding population changes, understanding movement changes, understanding, let's say, things like an aging population, will help you make better forecasts, especially if your KPI is quite sensitive to population changes, to changes of the underlying population. The second reason why you should consider adding synthetic data to your MMMs is it enables multi-objective optimization. If you develop an MMM, depending on what your objective is for your MMM, whether that's sales or whether that's brand index, whether that's, I don't know, the number of new customers, your MMM is going to be optimized based on that objective. And sure, you can build multiple MMMs to optimize against multiple metrics, but there are some things that you simply can't do with just MMM data. For example, if you're looking at optimizing reach and frequency along with your main MMM objectives, reach and frequency is not something that you would necessarily have, but now that you have population data, along with things like media spend and CPMs, you could fairly easily work out your CPM, your reach and frequency as well. And from that, you can develop MMMs that optimize against either or both of those metrics. Having synthetic data brings plan, measure, activate all in one. So traditionally, especially in my agency days, building an MMM and delivering it to the hands of the planners is very difficult. People build an MMM, you create some nice decks, and you pass it on to the planners. The planners read it, and they continue to do what they do. There is a nice tool that can help them take the MMM and activate. But now with synthetic society, you can very easily do that. When MMMs are built, our planners could very easily import MMM coefficients into their day-to-day media plans. They could map out their audience on the map. They can export things like geographies or device IDs from which they can then target against their target audience. So it really brings planning, measurement, and activation all together. And lastly, bringing synthetic data into the MMMs allow you to extrapolate your learning to new cohorts. So for example, you build MMMs for one particular geography. Maybe there's a new area that you're thinking, a new media that you're thinking about trying. You have no historical information on that whatsoever. It would be difficult if you rely just on the MMM. If you want to know how your media might perform in a new market or in a new media channel, but with the synthetic society, with adding in consumer behavior, it allows you to take your learning from one particular area and at least make a projection, make an extrapolation on how your media would perform, what your ROAS may look like if you were to bring your model to a new market. All right, I'm gonna stop right here and pass it on to my colleague Robin to go through her slides. Robin, over to you.
Thank you, Winston.